Okay, so here we go on practice exam number 2, part 2. Notice the note 12.3, section 12.3 is not covered here, but will be on the exam. See the notes. That's the constructions. That's the ones where we make, copy angles and make perpendicular lines and make parallel lines and make triangles with angles 30 degrees and 60, and you need your protractor and your compass and your ruler, all that will be on exam number 2. It's just not on this practice exam because there's not any way for me to actually put it on this practice exam. But I want you to remember to go back and practice the 12.3 notes so that you'll be ready to go for that. Okay, let's go. So they say triangle NAP is congruent. That equals with a squiggle means congruent, and congruent is the same thing as identical. So in geometry, when we say two things are congruent, we mean they're identical. So how do we know? So let's draw what they're saying. We have triangle NAP, and then over here, triangle DOG. So I had to go in the same order, right? N on the left, A top P right, and then D left, O top G right. Nap and dog. Okay, so they're identical triangles. So does that mean, here comes their questions, is NP, which would be that side, equal to DG? Is that true? Yes, that's true, since the triangles are congruent, and NP corresponds with DG. Next question, is angle A, this one, equal to angle D? Is that going to be the same as angle D? No, they're different positions, huh? No, angle A and D are not corresponding. They're in different positions. A is at the top, D's over here at the left, right? A was in the middle here, back to the original statements. A was in the middle and D was in the front. So they're in different positions of the congruence statement, right? They said they're identical, but they said it in a different order. A's in the middle, D's in the front. So no, that's not true. And how about question C? Is AP equal to DO? So AP, this side, equal to DO, that side? No. No, again, they're in different positions. AP's the last two, DO's the first two. Different sides of the triangle, different positions. No. So that's all about knowing if things are corresponding or not. Number 2, determine the congruent triangles. Okay, so is this triangle and this triangle, are they identical? Remember, congruent means identical. Are they identical or not? Well, we have this side the same as that side. We have this angle the same as that angle, both right angles, 90 degrees. And they both share that middle side. That middle side is the middle for both of them, and it's the same as itself. So that makes side, angle, side. Side, angle, side. Yes, so those two triangles are identical by side angle. So we'll come down here. I'll answer this question right now. They are identical to each other by side, angle, side. Remember, every three-letter combo, side, angle, side, angle, side, angle, 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 side, 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 oh, not that one, not the bad word, not ASS or SSA, not those two. And also, AAA is only for to make triangles similar. But all of these ones, and it's also SAA, those all prove identical. Remember, every three-letter combo proves identical. Let me put that on all those, except for the bad word proves nothing, and AAA only proves they're similar. Right? Similar means they're the same, but one might be bigger. Same exact shape, but one's a bigger version or smaller version of the other. So that's what similar means. But identical, that's congruent. Congruent means they're totally identical, all the angles the same, all the sides the same. Similar means they're the same shape, but one might be a bigger version. than the other. So it's getting back to it here. So these two triangles are identical by side, angle, side. Okay, and how do we write it? EFH, the order matters here. EFH, that's going to match up with what? So EFH, E matches with G. So G, H, F. G, H, F. Do you see that? That order is really important. How do we know it's that order? How do we know it's not G, F, H? You know E has to go with G. Those are easy, I think, right? E has to go with G. But why the last two? Well, do you see how you have to, EFH finishes with H, which is the right angle in that triangle. EFH finishes with the right angle. So we got to do the same thing with GHF, don't we? So that is GHF finishes with the 90-degree angle. So that's the correct order. That's the right order to say those two triangles are identical. See that again one more time. So getting back here. E matches with G, right? You can see E and G play the same role, right? They match. But what next? So E, they wrote EFH here, EFH. That has to match. E has to match with G, and H at the back has to go with F. Why? Because H finishes with the right angle for this triangle on the left, and for the triangle on the right, GHF, F finishes with the right angle. So that has to match that way. All right, determine the corresponding congruent sides. So EF is the same as what? Well, you can just look at the triangles here. EF matches with GH, doesn't it? GH, or you can write HG, it doesn't matter, either way. And next comes EH. So EH matches with FG. FG or GF, it doesn't matter. And then finally, FH, this side, matches with itself. HF, or you could just say FH again. It doesn't really matter. And then determine the corresponding angles. Angle E is the same as angle G, isn't it? And angle EFH, where's that? EFH, this angle is the same as what angle in the other triangle? CHF, this one, right? Those angles are the same. And you say that CHF, on that, or so that's supposed to be G. G, this is a G up here. GHF. And finally, F, let me erase all my marks here. FHE, that 90-degree angle, matches up with what? HFG, or you could write it GFH. That's the same thing. That's the same angle. Or this other one you could have written, by the way, also FHG. That's the same angle on that one, and these two are the same angle. As long as the F's in the middle, right, you're getting this angle, right? HFG or vice versa, GFH, same angle. There we go on that one. So that's a good problem. All right, number 3 here. So, if we have a triangle, two sides, 10 and 14, what can you say about the length of the third side? Well, if you add 10 and 14, 24, and if you subtract the bigger one, 14 first, 14 minus 10, you get 4. That's the limits for the third side. The third side must be greater than 24. On that, wait, no, not B there. must be less than 24 and greater than 4. The third side must be between those two. The third side must be between 4 and 24. Remember that? That's because, you know, if you imagine, like if you had one side that was 10 and another side that was 14, that's what we're saying, one side's 10, one side's 14, then the third side, it can't be 24 or bigger. Why not? Well, because if you stretched these two right here, this one and this one, out as far as they would go, 10 and 14, then they would barely reach the 24, wouldn't they? And they can't quite reach the 24. Do you see that? They got to be less than 24, don't they? They're not going to reach all the way to 24, right? The third side has to be something less than 24, because the 10 and the 4, at most, if you made it completely flat, if you took the 10 and just brought it flat, 10 and 4 would make 24, but they're not flat. They got to come out a little bit, and so this side's got to be less than 24. And the same way with the 4 thing, the reason it's got to be greater than 4 is because if you have a side that's 4 and 10, the most they couldn't really reach the 14, right? So it has to be less than 4. So there we go for that. It would have to be, this would have to be a number, I'm sorry, not less than 4. This had to be a number greater than 4, like 5. It'd have to be 5 or something, right? Because this has to be longer than straight. If you're going from A to B, the shortest path has to be a straight line, the 14. The 5 and the 10, 15, that's longer because it's not a straight path. You can't make that 4 and say it's the same. It's the same to go around as it is to go straight. That can't be. It has to be something bigger than 4, like 5 or more. All right, number 4. So they're going to ask us for some different questions here. The first one is a triangle with angles. Well, here we can go to number 4 here. A triangle with angles measuring 60, 70, and an included side of 8. So we have a triangle, 60 degrees, 70 degrees, and a side between them that's 8. So if you have another triangle that's 60, 70, and 8, can those be two different triangles, or do those have to be identical? Well, they have to be identical. This triangle and this triangle would have to be. Why? By side, angle, side. I'm sorry, angle, side, angle. Angle, side, angle, right? This is an angle, side, angle. Angle, side, angle. So by angle, side, angle, they have to be identical. So they're asking, is it possible to construct two non-congruent, like not identical? No, it's not possible. They'd have to be identical by angle, right here, B, angle, side, angle on that one. Now the next one, 60, 70, and non-included side of 8. 60, 70, 60, 70, and non-included on a side of the 60. So that 8 has got to be on the side of the 60. So the 8 can't be over here. It's got to be over there on a side of the 60, like that. Not included. It's not between the 60 and 70, but it's on the side of the 60. Well, can you make two triangles like that are different? That's what they're asking. Is it possible to make two non-congruent triangles, two triangles that are different, that have the same 60, 70, and an 8 on the side? No, because this is side, angle, angle. Side, angle, angle. Or you could put it the other way, angle, angle, side. Watch, it's not the bad word. So that means they've got to be the exact same triangle. Any triple letter combo other than the bad word, ASS, or AAA is okay, right? ASS proves nothing, and AAA proves that the two triangles are similar, but not identical. One could be a bigger version or smaller version. So this is identical, right? AAS is identical just like ASA is identical. Any three-letter combo other than the bad word or AAA proves identical. So we would say by AAS, it's not possible. These triangles would have to be congruent. How about part C down here? What is part C? They're saying 3 angles. So we have 30, 70, 80. 30, 70, 80. Same 3 angles. Well, AAA, they're similar, but one could be a big version and the other a little version having the same 3 angles. So they're similar, but they're not identical. So is it possible to construct 2 non-congruent, not identical? Yes. Yes, indeed. It is possible because they determine a unique shape, but not size. There could be a small one and a big one. And that have the same 3 angles, and they're not congruent. So it is possible to make 2 triangles that are not congruent having AAA. So remember, AAA only proves they're similar, same shape, but not the same size. And ASS, the bad word, proves nothing. All the other 3-letter combos prove that the 2 triangles are congruent, meaning identical. Number 5, classify each of the following as true or false. No trapezoid is a square. No trapezoid is a square. Well, if you have a square, remember what a trapezoid is. Trapezoid, shaped like this, right? What's the definition? 2 or more sides are parallel. That's a trapezoid. See how the top and the bottom are parallel, but the right and left are not? Now you know what a square is, right? So, do you realize a square is a perfect trapezoid? Why? Because the top and the bottom are parallel, and so are the right and the left. 2 or more. So anything that has 2 or more parallel sides is a trapezoid. So a square is technically a perfect kind of trapezoid. So when they say no trapezoid is a square, yes, this is both a trapezoid and a square. So some trapezoids are squares. Perfect trapezoids are squares. So that's a false statement. How about the next statement? A rhombus is a parallelogram. A rhombus is a parallelogram. So what is a rhombus? Remember, it's like a diamond. Oops, I'm not making a very good diamond. A rhombus is a diamond. There we go. A diamond. So 4 equal sides. Rhombus, 4 equal sides, and it is a parallelogram. It is a parallelogram. Opposite sides are parallel. Remember how we used it in constructions? Whenever we make shapes, we made all those diamonds, and the opposite sides were guaranteed to be parallel. So a rhombus is a parallelogram. So that's a true statement. A rhombus, indeed, every rhombus is a parallelogram. Anytime you make a shape with 4 equal sides, you've really made a parallelogram. That's true. All right, number 6, given triangle ABC and DEC with congruent parts is marked, what else is needed to show congruence? So notice on this one, we've only got 2 things. We got this angle is the same as this angle, and this angle is the same as that angle. So we've got 2 equal angles. But that's all, just 2 things. Remember, we need 3 things to prove that 2 triangles are identical. Well, what else would we need to complete it? That's what they're asking us in this problem. What else do we need? Well, side AB, if we knew AB was the same as what? Well, this one, huh? So that would be DE on that one. So right there, DE. If we knew AB was the same as DE, then there would be congruence by what? Angle, side, angle, huh? Angle, side, angle. Okay. Then alternatively, now here's another option. Alternatively, we could, let's jump down to here, BC, so let's get rid of this now. They're saying, forget this for a minute. Now we're saying BC, where's BC? Here it is. BC could be the same as what? AC there, huh? BC's, oh, I didn't do BC, I'm sorry. BC here. BC, there's BC, is the same as EC. BC's the same as EC, right there, EC. That would prove it, right? What would that prove? Angle, angle, side. That would be angle, angle, side. Angle, angle, side. Or, there's another way. Instead, you get rid of these two. You could have AC, this one, and DC, huh? So we'll say down here, DC. And that would also be angle, angle, side. There we go. So different ways to prove that these two triangles are congruent, identical. Number 7. So now we're setting up a couple of triangles, and they're saying that these two triangles are identical. See that identical statement? This triangle is identical to that triangle. By what reason? Well, this is 80 and that is 80, so those sides are equal. This is a right angle and this is a right angle, so those are the same. And this angle must match that angle because they're diagonal angles, what we call vertical angles, right? So that's angle, side, angle, isn't it? Angle, side, angle. So they are by angle, side, angle. And therefore, now once we've proven, we just showed that those two triangles are identical by angle, side, angle, then that means that all their angles and all their sides are the same because the whole triangles have been proven to be identical, congruent. That means every piece of them is the same, every angle, every side. So AB, side AB, this side, must be equal to this side, must be equal to ED, right? Here it is, ED. And by, now what reason? CPCTC. That stands for corresponding parts of congruent triangles are congruent. That's what that stands for. Meaning, if you have two identical triangles, if you have two triangles that are identical, well, then their matching parts, their corresponding parts, like this side and this side have to be the same, or this side and this side have to be the same, right? It just means matching sides, corresponding parts of identical triangles have to be identical. And therefore, this piece here must match this piece there, and the bridge must be 92 meters long. There we go. All right, number 8. Okay, so these can be tricky. There's going to be like 3 or 4 of these on the exam we take. Okay, so remember what we always try to do. So first, try to get all the angles. Try to get all the angles. If you can get all the angles, you're in business. So we have 30, 90. Remember, there's 180 total, so this must be 60. And this one must be 60. So these two triangles have AAA. So that's the second thing. If you can prove two, all you need is 2 angles. That means the triangles are similar. And what is similar? Whoops. Same shape. Same shape. Different sizes. May be different sizes, right? That's what similar means. If you can find AA, then that means the triangles are similar. Same shape, different sizes. Well, we've proven it. We got the same three angles. We got three angles. So yes, they are similar. Now, what does it take to prove that these are congruent? Well, for congruent, which means identical, they must have same angles across from same sides. So this 5 is across from the 60, and this 5 is across from the 90. That's different. So no, those triangles are not congruent. They're not identical because they don't have the same sides and across from the same angles. How about the next one? Okay, so remember step 1, try to get all angles. Try to get all the angles. Can we get all the angles? Well, remember, this is 2 equal sides. So across from 2 equal sides must be 2 equal angles. So this must be 65. And if we have 2 of them, 265, what's that have to be? 130, 65 and 65. So that leaves 50 to be 180. So that other angle is 50. Okay. Now, we don't know the other angles here. And there's really no way to find it. So do we know 2 angles in one triangle are the same as 2 angles in the other? We're not sure, huh? We're not sure because we only have one angle that's the same. Maybe the other ones are the same, maybe not. We just don't know. So there's not enough information on that one. Okay, but how about this? Are they congruent? So let's go down here to step 3 for congruence. Well, to be congruent, you have to have the same angles across from same sides. You have to have same angles across from same sides. Do we have that? We have, let's take a look. We have 3 across from 65, and here we have 3 across from 50. No, that's not good. They can't be congruent then. Congruent, you have to be congruent, you're totally identical. You have to have the same sides across from the same angles. All right, on to number 10. Are these triangles similar? So step 1, can we get angle? We're uncertain. We don't know. Okay, well, what are we going to do then? How are we going to do this one? Well, it just means we're not sure. We're not sure if they're similar or not because we only know one angle in this one is the same as one angle in that one, but we don't know the other angles, so they may or may not be the same. Okay, well, how about that here? Could they be congruent, which is identical? Could they be fully identical? Congruent. Remember what you have to have. You have to have same sides across from same angles. Do we have that? This angle is the same as this angle, but they're across from different sides, aren't they? Across from a 5 and across from the 4. So that's a no way. No way. Got to have the same angles across from the same sides. All right, one more of these. First off, can we prove 2 angles are the same? No, we're uncertain. We only have one angle here and one angle here. That's all we know. Okay, well, down here. What can we do with congruent? Congruent, identical. Is there anything we can do to try to prove they're congruent or identical? Yeah. Do you see what we have? Side, angle, side. Right? 3 angle 7. 3 angle 7. Side, angle, side. They have the same. These 2 triangles have the same side, angle, side, don't they? 3 angle 7, 3 angle 7. Matching. So remember, that's a 3-letter combo, which means they are identical. So yes, they are identical. And if they're identical, if they're completely identical in every way, for sure they're also similar. Now up here you say, yeah, but we weren't sure. We weren't sure at that point, but now we're sure. Now we're sure because we've proven they're identical. Those triangles are completely identical, so for sure they're similar. Similar just means they're the same shape. They may or may not be the same size. Well, we proved they're the same in every way. They're identical. So of course they're similar. So it's double yes on that. On to number 12. All right, so in this one, we got to find x and we got to find y. And so what we have to do is set up similar triangles to figure this out. Because we know these two triangles are similar. How do we know they're similar? Well, they have one angle the same, this angle and that angle. And then they also have the diagonal angles, right? Diagonal angles called vertical have to be the same. So then by AA, these two triangles are similar, meaning one of them's just a big version of the other. They're the exact same shape, but one's just a big version of the other. So that means, when you know they're similar, that means, so the sides are proportional, meaning equal fractions. So I can say x is to 32, right? Now I started with the small triangle and I went to the big. X is to 32. Now how do you know x corresponds with 32? Well, because the x is the side right here, which goes between the double arc and the no mark. The 32 is the same thing in the big triangle. He goes between the double mark angle and the no mark angle. That's going to match up with 18 and 24, right? Because the 18 goes between the single and the double in the small triangle, and the 24 goes between the single and the double in the big triangle. See how I still went small triangle to big? So I was small to big, small to big. So make sure, you keep the same consistent ratios when you do these problems. You can't change your mind halfway through. You could put the big on the top and the small on the bottom, but you've just got to be consistent. Whatever you do on the left, right, if you start with small here and then go to big, you got to do small and big on the other side to be consistent. Now, how do we solve that? We cross multiply. 24x is 18 times 32. 24x equals, just use your calculator. I'm getting 576, and the last step is to divide by the 24. X equals 24. So x has got to be 24. Okay, so now let's go back and see if we can get our hands on y. So I'm going to go back here again. We put stuff back to where it was. So we got, again, the double. Okay, so I want to get y. Well, I'm going to start with the small again. Small is to big. So the small, who goes with the y? The 9 is to the y, right? The 9 and the y go together. Like the what? 18 and 24. Let's use the same two, right? And then do the same thing, cross multiply. 9 times 24 is 18 times y. 9 times 24, 216. 18y. Last step to get y alone, divide by 18. I'm getting 12. Y is 12. Y is 12. There we go. All right, so number 13. Photocopy of a polygon was reduced to 55% of its original size. Then the copy was again reduced to 55% of its size. So basically it's like we're taking some kind of sheet and we're shrinking it down to just about half, 55%, and then we're shrinking that down to just about half. Does that make sense? This is 55% of the original. It's the first copy. Original first copy. And then the second copy is 55% of the last copy, just about half of the last copy. Okay, so what does that mean? For the first question, is the second photocopy similar to the original? Yeah. Anytime you expand or shrink something with photocopying, it's going to be similar to it. So yes, of course, that's the case. Yes, because the angles stay the same and the sides are proportional. See how the angles, these are all right angles? When we shrink it down, the angles are still 90 degrees. And we shrink it again, the angles are still 90 degrees. See how the angles don't change when we shrink something or expand something? But the sides do, right? Maybe this was 10 to begin with, and this is 5.5 now, and now it's, I don't know what, something smaller. Right? So the sides will be in the same ratio. They're proportional, but the angles stay the same. That's right. Now, the final question, what is the ratio of the corresponding sides of the second photocopy to the original? So second to original. Second to original. Well, every time we shrink it, it does a 0.55. It's 55%. Remember, 55% is the same as 0.55 decimal. Remember, the decimal goes back two places? So 0.55 decimal is the same as 55%. So if we're going to do a 55% shrink twice, then just multiply 0.55 times 0.55 on your calculator. Every time you shrink it, it multiplies it by 0.55. So that comes out 0.3025. 0.3025 rounded to 4 decimal places. It's about, what that means, that if you wanted to change that back to a percentage, we don't need to. But that's about 30.25%. That means the final copy here is 30.25% of the original. You get what's going on there, right? So the original, we shrunk it down to be, the first copy was 55%, a little more than half of the original. Then we shrunk it down to 55% of the first copy. That makes it only 30% of the original copy, 30.25 or 0.3025 decimal, which is what they want. All right, number 14. Determine whether the following pairs of triangles are similar. If they're similar, explain why. Okay, so is this triangle and this triangle similar? Well, notice their sides are all proportional, aren't they? The sides are all proportional here. What I mean is, if I take 6 divided by 4, I get the same thing as if I take 3 divided by 2. Right? Those are the same fraction. If you divide by 2, top and bottom here, you get the same thing. Those are the same ratio. So the sides are all proportional. That's side similarity is what that is. And what's the ratio? They want the small one first, the triangle, so I should have done it upside down. Right? They want the triangle ABC over triangle DEF. And what's ABC? It's 2 over 3. The ratio is 2 over 3. That's the scale factor, 2 over 3. All right, next part. How about these two? About this triangle and this triangle? Are they similar? Is one just a bigger? Are they exactly the same shape? That's what we had in the last one, right? These two are exactly the same shape. One's just a bigger version. That's called similar. Now on this one, are these two exactly the same shape, but one's just a bigger version? Yes, indeed, that's true. Here's how we know. 3 compared to 6, if you take 3 over 6, that's the same ratio as 7 over 14, isn't it? They both just reduce to be a half, don't they? If you reduce the fractions, they're both a half. And they have the same angle in the middle, so by side, angle, side, similarity, there we go, side, angle, side, similarity, they are similar. Their sides are the same ratio, proportional, we call that. Their sides aren't equal. This is not the same as side, angle, side identicalness. For that, the sides would have to be exactly equal, not just in the same ratio. This is side, angle, side identicalness. I'm sorry, proportional. These are just proportional, same fraction, right? 3 doesn't equal 7, 6 doesn't equal 14. They're just in the same ratio. So it's side angle side similarity. They're similar triangles by side angle side. And what's their ratio? It's a half, right? 3 over 6 or 7 over 14. Scale factor is a half. The small one to the big one is 3 over 6 or 7 over 14, both reduced to be a half. Part 3. Triangle ABE is similar to triangle ACD. Wait a minute, I'm not sure that's the answer. Let's see. So we have this angle, the same as this angle. Oh, by the way, what we're comparing here, let me make sure it's clear. We're comparing the little triangle to the whole big triangle. That's what we're comparing. So the little inside one right here to the entire big one. And we're saying, are those two triangles similar? Are they the exact same shape, except one is just a bigger version than the other? Well, this angle is the same as that angle. They both have the same upper right angle. Do they have another angle the same? Yeah. This angle, which is the left angle for both of them, that's the same in both triangles. So those angles are exactly the same. So therefore, it's got two angles. So by angle, 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 they're similar. So by angle, angle, they're similar. Now they want the scale factor. Okay, so they want us to take the little triangle, triangle ABE, over the big triangle, triangle ACD. So what's that going to be? ABE, 6, over the other one, 2. No, watch out. That's an easy mistake to make. It's not 6 over 2, because notice 2 is only part of a side, huh? That's not a whole side. What's the whole side of the big triangle? 8, huh? 6 to 8. So then reduce that, divide by 2, top and bottom, 3/4. So the scale factor there is 3/4. And then this last part of number 14, are these two triangles similar? Well, they have these diagonal angles called vertical angles equal, and they have these angles the same. So yes, by angle, angle. So we don't even worry about those sides. They have two angles the same. So yes, by angle, angle, they're similar. Now what's the ratio? Triangle ABE over triangle DBC is 6 over 8. Reduce the fraction, top and bottom by 2, 3/4. So they're similar triangles. Their similarity ratio is 3/4. All right, finally, number 15. Okay, they want us to find out things here, and they want meters in the end, so we better change these centimeters. 150 centimeters, we change that. That becomes 1.5 meters, because there are 100 centimeters in 1 meter. So we divide this by 100, and it becomes 1.5 meters. So I'll make this 1.5 meters. Cross that out, 1.5 meters. Okay, now we're ready to try to figure, what are we trying to figure out in this problem? The height of the tree, which means H right here. This is the tree. I want to find out the height of that tree. So basically, I've got similar triangle relationship here, don't I? So now let's be a little careful. So we have the big triangle and then the little triangle. This is H. This is 1.5. For the little triangle, this is 3. And then the big triangle, you got to use the 36. Don't you? Be careful. This is 36 for the big triangle. The bottom there, 36. Does that make sense there? So watch out. It's tempting to use the 33, but the 33 is only part of of the bottom of the whole big triangle. We got to use 36. So there we go. So h is to 1.5, h is to 1.5, as 36 is to 3. See how I did I started with the big triangle to the small, and I did big to small. You could go the other way. You could start with small to big. It doesn't matter. Just be consistent. It's good. Cross multiply 3 times h equals 1.5 times 36. 3 times h is 1.5. I'll use my calculator here. 36, 54. Last step to get h alone, divide by 3, and h equals 18. So h is 18. The height of the tree must be 18 meters. There we go.